All right, so the last couple days we did multiplication, division of rational expressions. Today we're going to do addition and subtraction. Why do you think they put that after multiplication division? Yeah, because I think addition and subtraction of fractions is actually a little bit harder than what multiplication and division is. Maddie, you all right? No? We haven't even started and you're already complaining. All right, now we're ready. Let's go back in time. And when we first, I tell you what, let's do this. I'm going to go back even further. Let's do a simple little fraction problem. Everybody watching? Everybody's up here, right? Okay. Let's do a little simple fraction. I'm going to make it really easy, like this. Okay. We're going way back in time now, hopefully. Back to elementary school days, probably. I have no idea when they first start teaching fractions. When do they start teaching fractions? 10th grade? Oh, definitely in elementary school. You should have. Oh, stop. Fractions? I bet you those kids in 2nd grade are doing this. Well, I'm just saying. I'm just saying, normally, you're probably learning this in elementary school. All right. My goodness. Set off a firestorm. All right. Is anybody going to listen to me now? Guys. All right. You had your little outburst. All right. Okay. What is it, Gage? Very good. Okay. Because now watch. The key to this, I'm not going to go to the very beginning and talk about what this means, okay? But I will go to at least to this point. When you add fractions, you have to find a common what? Denominator. Which one is the denominator? It's the bottom one. Common denominator. That's going to be key to what we're doing right here. Now, right here on this problem, they give you a common denominator. That makes it super easy, correct? So you just keep the denominator the same, and then what do you do to the top? Just add them up, right? If it was subtraction, right, addition and subtraction, you would subtract, obviously. So you just 3 plus 5 is 8. You don't keep it like this because we've been talking the last couple of days about canceling stuff out. So what is 8 over 2? That's 4. You could put it over 1 if you wanted to, but just leave it as 4 and just circle. There's your answer. Okay, that was super easy. Well, of course it is. What do you think? College algebra, and that's what all we're going to do right there with the common denominator? Come on. What about this? What if I had, let's do this, 3 halves plus 7 eighths. Everybody look up here. That's an 8. That's a weird looking 8. My 8s are the worst. Is that any better? Okay. So 3 over 2 plus 7 over 8. So let me show you. I'm gonna do this across instead of up and down. I know when you first learned fractions, you did stuff up and down, but now there's still a lot of people talking. I need you to listen to me. So I know when you were younger and you first learned fractions, they always did them up and down, didn't they? Okay, but I'm going to do them across. When we do algebra, we do things mostly across like this. So that's the way I'm going to do it. But it's the same idea. I'm just doing it horizontally instead of vertically. So can I just add them up? Can I go 10 over something? No, because I don't have a what? Common denominator. I have a 2 and an 8. All right, so what I'm going to do is this. Watch very carefully. I'm showing you these little baby steps because we're going to eventually do the same kind of thing, but we're going to do it with expressions, okay? Algebraic expressions, all right? Meaning you're going to have squareds in there, you're going to have x's in there and all that kind of stuff, okay? Right now we just got regular old little numbers, all right? So we have to find a number that 2 and 8 both divide into evenly, okay? Well, 8 doesn't divide into 4, okay? It's got to be a greatest common factor. It's got to, what's the biggest number that all of these, well, actually, let's call it a least common multiple is what it's called. It's a LCM. Do you remember that? LCM, least common multiple. So what number does 2 divide into and 8 also divide into? 8. 8 is the number. Because 8 goes into 8 once, 2 goes into 8 4 times, correct? All right. What if you don't know how to do that? Well, I'll show you. Watch. Here's a little trick that I do. This may, I don't know if this is going to confuse you more than anything, but if you're not sure what the common denominator is, this is what I do. I take the two numbers, guys, I take the two numbers and I break them down into their prime factors. What does that mean? Well, 2 is already prime, isn't it? What about 8? I can break down 8. What times what is 8? Well, 4 times 2. I can break down 4. What do I get? 2, 2, and then 2. So what I'm going to do, let me do that. Let me just move this over a little bit. What I'm going to do is this. I've got a 2 here, and I got 3 2s over here. To find the least common multiple, what I do is I find out what numbers show up in both places. Well, 2 does, right? I got a 2 here, and I got 2s over here. But which one shows up the most number of times? Over here. 3 times, right? So I go 2 times 2 times 2. So that's my common, that right there is my least common multiple. As we do more of these, I might show you more of this, okay? Anyway, that's how you do it, all right? We'll eventually come back to something like this. So the common denominator is 8. Now, here's what I do. We're going to do this with algebra stuff, okay? I'm showing you this, how to do this on the real easy stuff, because we're going to eventually go to this expression thing. So what I'm going to do is say, what did I do to the 2? Or what did I multiply the 2 by in order to get to that denominator? Multiplied by 4, didn't I? Oops, there goes my pen. Oops. All right, so I multiplied this by a 4. Now, I can't just multiply the bottom by a 4 and because 3/8 is not the same as 3 over 2, right? So if I multiply the bottom by 4, what am I going to have to also do? Multiply the top by 4 as well. What allows me to do that? Well, 4 divided by 4 is just 1. Am I allowed to multiply anything by 1? Yeah, of course. It doesn't change it at all. So really, I haven't changed the value of it at all, have I? The more we do these, the more you'll see. I'm seeing blank stares on your face. Blank looks on your faces. So 4 times 3 is 12. Okay, so we put 12 over 8. Is 12 over 8 the same thing as 3 over 2? Absolutely. Okay, if I reduce this, right, 4 goes into this 3 times, 4 goes into this twice. Yeah, so 12/8 is the same thing as 3 over 2. Now, do I have to do anything to this 8 right here? No, because I didn't change it, right? I just went from 8 to 8. So what am I going to do with the 7? Just leave it alone. Put it up there, though. I got to put it up there. All right? Now, I'm back to where I started on this first problem. Now I've got a common denominator. So I just keep the denominator the same, and what do I do with the numerators? Just add them up. 12 plus 7 is 19, and that's your answer. Don't change that to a mixed number. Just leave it like that. Okay? We're going to have to do what? Not too much. When you do algebra, most algebra teachers want you to keep it as an improper fraction. There are times, though, like if you did it in real life, if I was a carpenter and I added these together, okay, I wouldn't measure out on my ruler 19/8. I would definitely put this in as a mixed number, okay? But for right now, that would be what, 2 3/8, right? So I would like 2 3/8 inches or something like that, okay? So in real life, absolutely. But as far as algebra is concerned, as long as it's reduced, just leave it improper. That's fine, okay? All right, now let's do this. Now we're going to get into some letters instead of numbers. So what if I ask you to add these two fractions together? You're like, Mr. Hamrick, how can I add that stuff together? There's not even any numbers here. What's up with that? Well, you've had algebra long enough to know that you can still do stuff like this with letters, right? So right now, do I have a common denominator? I do. Okay, B and B. So what do I put here? B. Now what do I do at the top? Just add them up. Okay, I don't have to change anything because I already had a common denominator. So what's the top right here? A plus C. It's not AC. It's A plus C. All right, just like that. Right? We did that earlier. Subtraction is the same thing. No big deal. What if I did this? A over B plus C over D. So, do I have a common denominator? I do not. I got to find a common denominator. What's an easy way to find a common denominator? Just multiply them together. Okay, I got a b here, I got a d here. How can I find the least common multiple? I just multiply the two things together. That means d will divide into it and b will divide into it if I multiply them together. So look at this. bd is my common denominator. All right? Now watch this. What did I do to b in order to get this denominator? What did I multiply b by in order to get this? Times it by d. Exactly right. So if I multiply this by d, what do I have to do to the top? Multiply that by d. See that? All right. Before I write it down up here, let's do this one right here. Now, what did I do to this d in order to get to this denominator? What did I multiply it by? A b. So if I multiply this by b, what do I do up here? Multiply that by b. And now we're ready to get our answer. So what's our top? AD plus BC. And that would be the answer to something like that. Okay? We're getting there. We're getting there. We're working our way up to the problems that we're really going to be doing. So here's an example. Example 3A. So we're just going to stop at example 3. We got A and B. All right? So let's do this one. This one... Oops, I'm sorry. It's not example 3. It's example 4. Example 4. Sorry, I was looking at the wrong page. It's right in front of me, and I was looking at the other page. So here it is. At first, it's going to look really difficult, but when you step back and then look at it, you're like, oh, yeah, this is just as easy as, well, it's almost just as easy. It's doing that 3/2 thing that we did. Why did I say this one is super easy right here? Because of what? The common denominator. That's right. Now, they're not always going to do this. Don't get too used to this, all right? But in this particular case, they're warming you up for the next stuff. So they already gave you a common denominator, so I'm just going to write the denominator. Do I have to change anything? Did I have to multiply this by anything to get to 2x plus 5? No. So I don't change anything up here. So what am I going to write up here? Just 2x squared minus 4, what? Plus, right? That plus, and then x plus 3. Do I circle that and use that as my answer? No. Why not? You got to add like terms. Very good. So look at the top. Are there any like terms up here? Yeah, there's two. Or there's two numbers that are like terms, okay? Are there any other x squareds up here? No. So I just write down 2x squared. Are there any other x's up here? Nope, so I just put plus x. Now, I can add this one and this one. It's negative 4 plus 3, which is negative 1, over what? 2x plus 5. Okay? Now, we just finished doing this, so don't get mad at me for this. But you don't leave it like this. Why not? Actually, technically, after we do the next step, you could leave it like this, but we're not going to. Watch. I'll show you what I mean. What does this look like? It looks like we could do something with this. What does it look like we could do to this? It looks like we could factor, correct? I never said we were done with factoring. You always have to factor. Now listen. Shh, shh, shh. We're not listening. You need to factor because if there was a 2x plus 5 up here, what would they do? They would cancel out. And if you didn't simplify it all the way, you're not going to get it right. So we have to figure out, is there going to be a 2x plus 5 up here? That's why we need to factor this. Okay? And you could kind of look at it and know there's not going to be because this minus 1, this can only be 1 and 1 right here, correct? All right, so, but let's just factor it anyway. It's good practice. 2x and x. One's going to be positive, one's going to be negative. What times what is 1? 1 and 1. Does that work? Yep. Negative 2x. Oh, that doesn't work, does it? Because look, if I multiply the outside, that's negative 2x. If I multiply the inside, that's 1x. What's negative 2x plus 1x? It's negative 1x. Is that negative 1x? No, so what should we do here? We should switch and make this one a negative and this one a positive. Now let's see if it works. 2x times 1 is 2x, minus 1x is 1x. Yep, that works. But the only reason we did that is to see if anything would cancel with the thing on the bottom. Does anything cancel with the thing on the bottom? No, it doesn't. So you could, depends on your teacher, you could keep your answer like this, or you could keep your answer like this. I'm not sure what they put in the book. I think I circled both of them, and I put an or. So I'm fine either way, all right? But here's the deal, though. What if, when you did this factoring, what if this was a 2x plus 5? What if it was? Then they would cancel. Then your answer would be this, so you would not be able to leave your answer unsimplified. Okay? I hope that makes sense. Stop. Wow. All right. To do this one? Is that right? Have you looked at it already?
Just a little break. Just a little break.
A little break? Come on. Right, there's only 2 minutes left. That's my point. So why would you need a break if there's only 2 minutes left? Wow. Crying. All right, here we go. There's one thing we need to do here that we need to cover. Watch this. First of all, it's an easy one. Why is it easy? Because you got a common denominator. So now, what do we do with the top? Just write down the top. But here's what you got to be very, very careful about. Everybody look up here. Come on now. This is a minus. You're subtracting. Guys in the back, you keep saying it's hard. It's because you're not looking up here and you're not paying attention. Will, come on. I'm talking to you. Don't make me call your name. You know I'm talking about you. So look. You're subtracting this whole thing right here. So what do you have to do with that negative? You have to, give me a good math word. Boom. Distribute. Right. So what's this going to be? It's going to be negative what? 3x. And it's going to be what? Minus 2. A lot of students would put minus 3x plus 2. But is that correct? No, because that negative is being distributed through this whole entire numerator. Okay? Are we finished? Do we circle that? No. Put the x minus 3 on the bottom. What can we do here? What's x minus 3x? Negative 2x minus 2. All right? And you could just keep it like this. Now, you could technically factor a negative 2 out of this if you wanted to. And this would be this. All right? But there really wasn't a reason to do that because this doesn't cancel with this. All right? But you got to be aware of it. You got to be very aware that if you can factor it, I would factor it because I would look to see if anything could cancel. Because if something could cancel, you need to cancel it or it's not going to be completely right. Everybody got that? So I would either, in this particular case, you could keep it like this or you could keep it like that. Because the only reason I would let you keep it like this is because nothing cancels anyway. All right? So if it doesn't cancel, then you're good leaving it like this. But sometimes you'll get a problem where this thing right here might factor out to be an x minus 3, and it's not an x plus 1, and then you have to cancel it. It didn't have it on this problem, but it could. Everybody got it? Okay. So I am not going to give you any homework because on Monday, we did common denominators today. Guess what we're going to do on Monday? Uncommon denominators. Okay, so we're going to get denominators that are not the same. That definitely ramps it up a little bit. Okay, so hopefully you understood what we did today. All right, enjoy your weekend. No homework. Good luck in the games today.